In this video, we're going to go over some vocabulary terms in statistics as well as sampling techniques. To begin with, let's talk about the difference between a qualitative variable and a quantitative variable. A qualitative variable is categorical. So if I talk about the color of the vehicles that are parked outside of a store, those colors are going to be categories. That would be an example of a qualitative variable. If we talk about the type of food that someone likes to eat, if we were to talk about the size of the luggage that people take to the airport, those would be qualitative variables because they describe a category. Now, on the other hand, we have quantitative variables, and a quantitative variable takes numerical values representing counts or measurements for which arithmetic operations such as adding and averaging make sense. So quantitative variables could be the number of children that a family has. It could be the number of desks that's in a classroom. It could be the number of flights from a particular airline. It could also be the height of a child or SAT scores, or basically a lot of standardized scores are going to be numerical. So those will be quantitative variables. If a variable is quantitative, you can continue to break it down into either discrete or continuous. Discrete quantitative variables basically are data that is distinct and separate. When you say the number of pets that a family has, you can either say 0 or 1 or 2 or 3 or 4. Each one is distinct and separate. You cannot break it down any further. If you talk about height, time, weight, mass, amount of carbon dioxide in the air, all of that is going to be continuous because you can keep breaking that down, okay? So continuous quantitative data describes data that can be measured and broken down further and further and further. Then we're going to talk about the difference between population and sample. Population is the largest collection of entities for which we have an interest at a particular time. Population is the idea of all or every. So if we talk about the registered voters in the state of Texas, all registered voters in the state of Texas would be the population. Sample is a subset of the population. So in the particular case that we're talking about all of the registered voters in the state of Texas, then a sample could be 50 registered voters from Dallas, Texas, okay? So that is basically the difference between a sample and the population. We have also what's called a parameter. A parameter is a numerical characteristic of the population. So if I want to talk about the median household income of all of the people who live in California, okay, California is a really big state. So the parameter there is the median household income of all the people in the state of California. Now, think about it. There's a lot of people in California. So instead, it's more feasible for us to find the median household income of a sample, perhaps 100 people who live in LA, which is a city in California. So that is called a statistic. A statistic is also a numerical characteristic, but of the sample. And I want you to realize S in sample, S in statistic, and P in population, P in parameter. So that's the difference between population and sample, parameter, and statistic. And notice also that we talk about the course name is statistics. It's really not called parameters because it's really not feasible a lot of times. It's very costly, very time consuming to gather data for an entire population. And so it is important for us to look at samples instead. In looking at samples, we're going to be talking about sampling techniques. How do we find samples that are going to be representative of the entire population so that we avoid sampling errors? And so we're going to talk about 3 basic random sampling techniques. The first one is the simple random sampling. This one a lot of times is referred to as SRS, okay? Simple random sampling. Basically what you do is take a population of size n, you number each person or object from 1 to n, and you're going to use a random number generator to select a sample size of n. This is the most elementary type of random sampling, and it's also probably the least costly. So think about a school. Let's say we have the school Jackson Senior High School. And in Jackson Senior High School, we have 500 seniors. So we want to set out a survey to find out what colleges these seniors are going to go to. But to ask all 500 seniors is going to take a long time. And we don't have that much time, let's say, for us to conduct this survey. So instead, we're going to go ahead and number all 500 seniors in the school. And we're going to choose a sample of, let's say, 50 seniors, okay? So then once you have listed all the seniors from 1 to 500, you're going to use a random number generator to select 50 seniors. You would then match the numbers to those names, and then you would go and ask those 50 students. What are some of the problems with sample random sampling? Well, in the example that I told you, if those 50 students who were randomly selected comprise of my sample, I would have to go and find every single one of them. Let's say that somebody doesn't want to participate. Let's say that somebody has been absent for a long time. So that presents problems also for our sampling technique. Another type of sampling technique is called the stratified random sampling. The main thing about stratified random sampling is the fact that first we're going to divide the population into subpopulations, and that is called strata. One sample is selected from each strata. The collection of all the samples from the strata is the stratified random sampling. So this has the potential for reducing sampling error. Imagine that we are going to introduce a new course to a high school. Okay, so in Jackson Senior High School, we have 9th grade, 10th grade, 11th grade, and 12th grade. If we were to just do a simple random sampling where we list all of the students and randomly select them, it is possible that perhaps I get no freshmen in my sample, or perhaps I get no seniors. So what happens in a stratified random sampling is that first I'm going to divide the population by, let's say, grade level. So I would have to pick, if I'm going to pick 80 students total, it would have to be 20 who are freshmen, 20 who are sophomores, 20 juniors, and 20 seniors, okay? So the idea there is we have potential for reducing sampling error because we at least are going to hear from all the grade levels in terms of what course they want to get added to the curriculum. Also, we have the potential to match the sample closely to the population is greater than with random sampling because portions of the total sample are taken from different population subgroups. This, of course, does tend to be a little bit more costly because it will take you time to go ahead and subdivide the population. And then within each strata, you're going to randomly select them. Another type of sampling is called systematic sampling. This one, a lot of times, I refer to as the assembly line. So if you go to an assembly line and you're going to choose every 10th item, every 20th item, that's an example of systematic sampling. It's considered random sampling because everyone still has the capacity or the ability of being selected and chosen. However, it's done, very systematically. You would take the total population size and you're going to divide it by the sample size, and that's going to determine which item you'd want to be selecting. So remember, if k is not an integer, if that answer that you got when you divide it, it's not an integer, you want to make sure that you use a whole number so that you select every 10th, every 12th, every 27th person or item. A lot of times systematic sampling is not done in an attempt to reduce sampling error. Instead, it is used because of its convenience and relative ease of administration, and it's evenly distributed across a population. So those are 3 random sampling techniques. Then we're going to talk about 2 non-random sampling techniques, okay? So this does not involve random selection. And there's going to be a third one that actually I'm going to write down for you, but so far we're going to talk about these 2. The first one is convenient sampling. Convenient sampling is just that. It is convenient. A researcher typically chooses elements that are readily available nearby or willing to participate. So, in contrast to a random sample that would require the researcher to gather data only from the individuals or cases that have been randomly selected, no matter how inconvenient or unfriendly. So, in convenience sampling, this is the idea that you want to find out, like I told you, what will be a new course that you want to introduce to the curriculum. And so you are set out to figure this out. Your school has a population of 2,000 students, but you decided to ask those people in your class. So maybe you have a class of 30 students, and that becomes your sample because it is convenient. You happen to be there already. It's going to be really fast because you're just going to ask them all to tell you what's the course that they want. Is it really representative of the entire population of the school? Perhaps, perhaps not. Most likely not, okay? Because let's say that you're not in a mixed grade level class. You might only be asking juniors or you might only be asking sophomores. But again, it is still very convenient. Sometimes when you're listening to a radio station and they're asking you, call in if you have a funny story about the first ticket that you got from a police officer, then again, it has to be somebody who really cares enough to share their story, who's going to actually take the time to call in. So that would be convenience sampling. Quota sampling appears similar to stratified random sampling in that you're still going to first subdivide the population into different groups. But instead of selecting a sample from each stratum, we're going to use a non-random sampling method to gather data from one stratum until the desired quota of samples is filled. So in the example of the course that you want to add to the curriculum, let's say you're going to stand outside of the cafeteria and you're basically going to ask 20 freshmen, 20 sophomores, 20 juniors, 20 seniors. So you're going to start asking the students as they come out of the cafeteria. And once you've filled all your slots for freshmen, you have another freshman who comes and you tell them, oh, what grade are you in? And they say ninth grade. You're like, oh, no, thanks. I already have all the ninth graders that I need. And then you kind of keep going until you fill all the quotas of sophomores, juniors, and seniors. So that's different from the stratified random sampling, where every single person within each strata still has an equal chance of being selected. In quota sampling, you're going to be asking until that is filled, and that's it. Nobody else is allowed to participate because you met your quota. What are some advantages of quota sampling? Well, it's less expensive. It's technically a technique of convenience. Data gathering is fast since we don't have to call back or send out a second questionnaire. Disadvantages is that it still remains a non-random sampling technique. So another type of non-random sampling technique is judgmental sampling or judgment sampling. In this case, the researcher selects units to be sampled based on their own knowledge or professional judgment. So let's say that we're going to conduct a survey on students' attitudes towards moving away for college. Okay, so going to a different state for college. And as the teacher, I'm going to say, okay, well, I think I'm going to select these 5 students because I'm pretty sure that they are going to go to college. That is definitely not going to be random selection because not everyone in the class is getting a fair chance of being chosen. Instead, I'm using my expertise to select the students who are going to be surveyed. In doing so, there's definitely a lot of bias in this sample because it could be there's somebody has a really good opinion about going away for college, but maybe I don't have that relationship with the students, so I have no idea that that's what they're planning on doing. So there you have it. Here is some of the vocabulary that is super important for you to know in statistics, as well as the random and non-random sampling techniques that you should be aware of.